Hi guys, and welcome back to Big Data for Engineering. In today's tutorial, we're going to work with a lot of different AWS stack. So we will work with AWS Lambda, Kinesis, S3, DynamoDB, Cognito, and Athena to build a real-time data processing app on AWS. So don't worry if you are unfamiliar with all of these tech. Let's just quickly go through the problem we have here. So we're trying to have like a fake data of all of the unicorn delivery fleet here, and we try to capture the data where there is moving around during the delivery, and all of those data will be logged onto different services on AWS. So first of all, we will build the data stream with Kinesis to read the stream of data from all of those unicorns on the live map, and then we go into aggregate all of those data to measure the health and distance travel each minute. Then we go into process the streaming data and store it on the DynamoDB. We can also store and query data where we just save the raw data on S3 and using Athena on top of that. So all of these sound very unfamiliar with you guys at this moment because many of you have not touched AWS before. So I'm trying to translate it into something you guys know before. So basically, Kinesis is just the AWS version of Kafka, let's say like that. So Kinesis data stream here is like the data streaming services of Kafka is taking the data stream coming in. Then with data analytics, you can perform some of the very quick ETL process, which means just trying to do some of data aggregation here. Then you can put them all together and output in DynamoDB. And on the other hand, we got the Kinesis file host. This is similar to a consumer in Kafka, which means it's going to take in the stream and then it would put it into a storage. In this case, it's going to be S3, which is a blob storage. So quick introduction about S3, if you're unfamiliar with that, it's just like a blob storage. It's like HDFS, but without the whole replication things. But is still very high availability, if you can say that. So when store is stored on there, it's just raw data, so you can store image, video, or text file. That's why we got Athena here. So Athena is similar to the data table that I already introduced you guys during the data break. So it's allow you to run SQL query on top of the raw file stored in S3. Okay, so that's just a quick introduction about the full stack on this tutorial. Now I'm not going to keep everything exactly like this. I'm adding a little bit of my touch on that. So what I updated, the first thing is that in this stack here, they trying to use the Cloud9 IDE. So quick introduction, Cloud9 IDE is just a cloud-based IDE environment where you can just write script and run your code on the cloud. So basically, it's just like an easy to instant where you can just put your code there and run it on top of that to interact with other AWS services. To me, this is a little bit unnecessary because we can totally run the producer to produce the data stream and put it on Kinesis directly from our local environment. And that's also better for you guys when you guys try to do assignment tree because you guys more familiar with how to write the code for integrating on the API here in this environment rather than trying to figure out how to set up the environment on Cloud9 IDE. But feel free to follow this exact step if you want to get an understanding, let's say a bit of Cloud9 IDE on here. The second things that I updated from them, so they already write some script to fetch the data of the unicorn delivery fleet. The script is in Golang. I understand that RMIT and SAT did not teach any of you guys Golang. That's why I translated that onto Python and allows you guys to run the Python script as the producer on local environment. So just quickly touch on that. Okay, so here we got the producer in Go language. So basically, they just import some dependency here. They have some constant variable to begin with. These are helpful for us to calculate the next location of the unicorn and also calculate the distance travel as well as the point on health point and magic point. So they define the variable type here, and then they started out with just trying to calculate the point for every single step here, and use this function to calculate the next distance based on the heading of just some randomly different heading of the unicorn and the distance it can travel within that. So, okay, I myself don't know about Go, but I know about data, I know about Python, I know how to read code, and I know a little bit of math. That's why I translate that into Python. So this is the Python that we are going to use. First thing first, please help me to install Kino. So Kino is just a Python library that allow you guys to use Python code here and have the Kinesis producer. So you can directly send data to the Kinesis stream, the data stream on Kinesis. Okay, quickly introduce this code here. So this is just to calculate the new location of the unicorn based on some correct math. It's not some math that I think of. It is the correct math that you need to calculate the next location based on the current latitude, longitude, the bearing, which is the heading, and then the distance that the unicorn travel. Then we generate some fake unicorn data here, including just the name here, the current time getting it from daytime, distance that it can travel. I'm currently set the distance between 28 and 32 kilometer maximum. And then we got the beginning latitude and longitude, and also just some random magic points and health points here. That's not important. And after that, I'm just going to get the fake data, and I'm going to call the producer here. And I'm calling the producer to put the record on Kinesic. Just very similar way that you call the function to put the data on Kafka. Okay, so that's quick introduction about this. Now let me just trying to show you guys how we going to connect to AWS first. So to begin, please sign into AWS Educate. Feel free to do this on your own AWS account if you want to. This whole tutorial might cost you maybe maximum $2, so it's not much. Okay, you guys might have a little bit different uh, layout than me, but basically what you need is just try to get to the classroom here and go to this classroom for if you're going to do the tutorial. If you want, use this one. Either way, it would be fine with me at this point. And I'm just going to the workbench here. So starting from the workbench, you can go to AWS console here. And to have the environment on the local setup for the tutorial, if you haven't watched my week 10 tutorial, not week 10, like the one on the AWS ECS and Fargate next week, then you should trying to set up the AWS command line interface. So you need to find and install the AWS command line interface. We need to use the version 2, so please don't use command line interface version 1. So just go in here and follow the installation instruction for your platform, which means for your operating system. Okay, so after you install that, and you just need to configure it for the first time. So if you want it for the first time, just call AWS configure. So you can put in some of the account detail here. Then after that, if you're not sure about what you have in there and you, for example, start a new session, then just go inside the location where they store the credential. So for Windows, it's going to be on C drive in user, your username and .aws here. For Linux and Mac, I think it's just in the root folder and then .aws. And the file you're going to need is the credential here. So basically this the thing that you need to replace. Just put the whole things here inside the credential. Okay, so even though here you see the session time is only about 3 hours, but if you refresh this page before that, like the session time is automatically like restarted from the beginning, I'm able to like put it like on the whole night without any interruption. And even if you got kicked out, then all of the resources you created on AWS is still there. Like you just need to have a new credential in here if you're going to use the command line interface to talk to AWS. So that's the quick introduction. Now let's get started with our tutorial. Okay, so because I'm going to skip the Cloud9 and I'm going to skip the whole Go thing, so we can go directly onto module one. So in module one, we just deal with the first step, which means trying to build the producer to send data onto the Kinesis data stream here. So the step include creating the Kinesis stream, and then we're going to produce the message from there. I'm not going to deal with the create message, which means just going to use the consumer. So basically the consumer here is just going to read the stream and print out on the Cloud9 batch, which is not very useful to me. That's why I'm totally skip that. I did not translate that from Go to Python, but ignore that. I'm going to show you guys the real consumer for Kinesis using the file host here later. Okay, now let's get started. We need to create the AWS Kinesic data stream. So just create a new data stream here. The name would be worldwide. And then we only need one shot, which is just limit us to 1000 data records per second. We can go to 2, but basically like we don't need that much, so just 1 would be enough. So this just take a couple minutes, not minutes, just less than a minute, yep, to start. So now it's already starting. We can try to put some data on there. So the command for this one would be Python, then the file here, the Kinesis producer.py, and then the stream would be Wirewise, and the name would be any name of the host, the unicorns that you want. Just a reminder, if you haven't installed Kiner, please help me to do pip install Kiner. So it's one quick. Okay, so again, just the stream here would be the name of the Kinesis stream on AWS and the name of the unicorn. Any name would be fine. Okay, it's starting to send a lot of data. I'm going to open another one on there. So we got 2 unicorn going at a time. So I call the exact same command, but I just change the name of the unicorn here. Okay, so we got two unicorn running around doing delivery for us. Of course, you can do the monitoring to check whether the data is coming inside here. It's going to take a little bit, mainly because the internet in Vietnam is really terrible at the moment. Just pick the custom 1 minute because if you wait for the 1 hour or so, it's going to take a long, long while. So still see no data in yet. Let's refresh it. Yeah, sometimes it take a little bit for the metric to show on this monitor things here. Yeah, if you know me, you know that I'm kind of very impatient. I'm not really good with waiting. Okay, we got some dot coming in here. It doesn't have any meaningful message now because it's just a dot. Like wait until we got like a line here, then you kind of understand a little bit about only this chat. Feel free to go back to here later if you want to take a look of them. Let's move on to the next step. So because we already produced the stream and then we see that, okay, so we got some data coming in, but we don't know where this unicorn are actually running. So this next part is not important for the not really like a must for all of the data pipeline, but it's just really helpful for you guys to see it in a visualization way. So we go into create the identity pool on the AWS Cognito service, and then we just use one of the map that they already have on the unicorn so that we can visualize that better. Okay, let's move on to Cognito. So Cognito is just identity management services on AWS. So manage identity pools here. Just give it a name. And then we go into enable access to unauthenticated identities. Allow. Okay, from here, just go to the dashboard. And then when this dashboard is loaded, of course, you haven't seen anything in here yet. Just go to edit identity pool. What we need from this one is just the ARN here. So just save this one in a note. You're going to need it to help with some visualization later. Okay, so basically the identity pool help us to trying to check where all of these unicorn going. Wrong one, sorry. Now let's try to create the IAM for the access to that. So basically we need to create the new IAM role. So IAM is just a service on AWS that allow you to know, okay, this IAM role allow to use this kind of service, and then we can use that to connect different service of AWS all together. So this basically a loss of security behind that. Okay, we're going to need to create the policy for the IAM home an authentication home here that allow that to talk to Kinesis and use the data coming from the Wi-Fi stream on Kinesic. Basically that. Okay, leave this one. Let's go to IAM here. Now just go to the host here. I cannot speak the R in Vietnamese as well and English as well, so bear with me. Let's just find the authentication host of Cognito. So this is the authentication host of Cognito. Just click on that. Okay, now we go into add inline policy here. Then we go into choose the service because we want it to talk to Kinesis. So we choose in Kinesis here. And now we allow that to list and read only. We don't really need to read to write back to Kinesis. We need to put the AIN in here. So basically we need to identify the regions where this stream are. So this US East one, and the stream would be worldwide. So in case you don't know about your region, just take a look in here in your account. But if you're going to use the AWS Educate account, you're going to be on US East one by default. You cannot use other one actually. Similarly, go into this US East one. Stream type would be stream. Stream name would be worldwide. And consumer name can be any. Okay, just review the policy. And you go into give it a policy name. You can keep the exact same name in the tutorial file, or you can put any other name. It really doesn't matter much. But yeah, I'm going to keep the original name, which is just worldwide dashboard policy. Policy. Yeah, let's write it better like this. And just create the policy. Okay, so now we see that it's got attached to the home here. Let's move on to the next step where you're trying to put it under the visualization dashboard. So basically this and a web that they created for us to try to visualize this unicorn fleet. So you need the Cognito Identity Pool ID for this one, which is the ARN that we copied before. Wrong one. And just click start here. Okay, let me zoom out so you see a bit better. So you see the two unicorn moving. Yeah, it started out as a straight line and then it start moving randomly just because I have too many random things in my code. Okay, so this is just for fun visualization. It doesn't help us with the ETL pipeline. Um, so let's move on to the ETL pipeline. If you want, you can play around with the producer by adding more unicorn onto here. Next step, we go into do some aggregation. So this is a very short ETL pipeline, just using Kinesic data analytics to get the data from data stream here, and then go into apply the schema and do some aggregation on the data stream itself, and then put back into another data stream. So this is very similar to the way that we did with Twitter. So we get data from Twitter and then we do some analysis on that, sentiment analysis, and then put back the sentiment score onto the Twitter sync, and then use that as the stream for the Kafka. So it's for the Cassandra. Okay. Going back to this one, we got Kinesis. So let's put the new Kinesis stream. So we go into create a new Kinesis stream. Just call it YY summary here, which will help us to get the stream out of the equation from the analytics. So going back to not this one, I need to go back to the other one. Let me just close that and close this one as well. So Kinesic, new data stream, just call it YY summary here. And again, I only need one shot for this one. Create a data stream. Okay, that should be good. Now let's move on to create the analytics application that's going to read in the stream. Just create the application, and then you just call it any name. We're going to use SQL. Oops. And then just create. Now we connect streaming data, and we're going to use the YYs, the raw data here as the incoming data. And then we go into discover the schema automatically. This is going to take a couple seconds, hopefully. Okay, so the schema is detected. So we got varchar and double here. We got double, integer. Yeah, that's look good. Just save and continue. Okay, so after this, we just go to the SQL editor. Yes, start application. Okay, while waiting for that to start application, I'm just going back to here and then just going to copy the SQL because I'm too lazy to rewrite this one. So this SQL queries is just go into get the data from the stream with this schema here. And then we go into calculate the sum distance, the minimum magic point, maximum magic point, minimum health point, and maximum health point based on the stream and hook by the time here, the minute time here. Okay, so let's run in this. It's going to take a little bit to get in the stream into the data, then do some calculation. So may take up to a minute. Okay, we already got the data coming in. Now let's just pick destination and connect to our destination. So that is the ETL pipeline. We do some transformation with the data. We extract it from the Kinesis data stream. We do some transformation. Now we just load it back into another data stream here, the wild summary, and then just use destination sequence stream, which is the one that we just run. Output format is JSON, which is fine. We can create a new IAM role for this one. Save and continue. Okay, so that's good. The application is up and running. Well, of course, you can go back to the stream here and then go to monitor and wait until you see some data coming in. But let's skip that and on to the next step where we're trying to put those data into not MongoDB, sorry, DynamoDB. So now to put those data into DynamoDB, first of all, we need to create a DynamoDB, of course, and then we're going to need to have the special IAM role that can use a Lambda function. So a Lambda function here is basically a function that helps us to process the stream coming from the Kinesis summary table into the DynamoDB table. So let's do one step at a time. So create the DynamoDB table first. Okay, I'm just going to copy this. So go into DynamoDB. Just leave. Create a new table. And the table name that you should have is unicorn sensor data. You can put another name. Just remember in the next step, you have to use the same name for some of other steps. So the primary key would be name, and then the short key would be status time. We're going to keep the default setting. Okay, so the table is created. We're going to need the ARN later, so just copy this just in case we need it later. Now, after doing the DynamoDB, we go into create the IAM in order to deal with that. You can follow the step in here. It's quite detailed to follow. Okay, now I'm just going to do those one by one. So first of all, of course, we need to go to IAM. And we need first to create a policy that allow us to write in bash onto DynamoDB. So it's a custom policy. So just here, create a new policy. Pick a service here and just search for DynamoDB. And in here, we need only bash write item. We go into identify the ARN as well. So this is just US is one. Oops. And the table name before what we have, Unicorn Center data. I hope I have the correct table name. I forgot it. Yeah, Unicorn Center data, but with capital letter. Okay, next is the tag. You're going to skip it. It's not very important. For the policy name, just put any name here that you want. For example, you can use the name yeah, just call it. Okay, so after you got the whole, the policy created, now you're going to need to uh, create the roles. So going into the role here and then create, and then you're going to need to create the Lambda one. So just Lambda, next. And in permission, we're going to need the policy that we just have. So it's the bash write policy that we just created. You're going to, and sorry, not all, and you're going to need to, to allow that to deal with the AWS Lambda Kinesis execution role. This one here, Lambda Kinesis execution role. Then skip the key tag here. For the name, just any name. For example, processing role, like this one. Okay, so after that, you're done with all this. Now we just need to create a Lambda function to get the trim coming out of the wildcard summary data trim on Kinesis onto the MongoDB, sorry, not MongoDB, DynamoDB table. So let's move on to Lambda. Just create function from scratch. Let's just give it a name. And because they have the assemble in Node.js, so I'm keeping the assemble. I'm too lazy to rewrite this one in Python. And I believe you guys understand this bit of code, so not going to rewrite it. They're using Node.js 10. We don't have it here, don't worry, just select 12. We can update it later inside the function. But the most important thing is trying to have the correct permission here. So you don't create a new role. You want the one that you have, the one with the custom policy that we already added. So you're using this one here. Okay, so the function is already been here. Let's just put this whole JavaScript inside there. So the JavaScript is just going to help us get the data from the data stream onto DynamoDB. So first thing first, let's update the Node.js version. Edit using 10x here, save it. Then if you read the code here, we have some environment variable, just the table name here. So I'm going to need to do the configuration. So inside the configuration here, there's environment variable, edit, add environment variable, the table name. This would be unicorn sensor data. Just double check if I got it correct. Yep, unicorn sensor data and save. In general configuration, it's recommended that we increase the timeout here because 3 seconds is a little bit too short. So just put it to 1 minute, 10 here. And using the same role that we created, click Save. Okay, next step, we go into add the trigger. So the trigger here means that whenever there's a new data coming in or something happen, some event happen, then the Lambda function will be triggered. So here you can see that we have different type of trigger, including AWS IoT, Apache Kafka. Yes, of course, like they do have Kafka on AWS. If you want, feel free to play around with it. But I think it's a good thing to introduce you guys to Kinesis on AWS. Just on AWS, like Kinesis is really, really popular. Okay, Kinesis. I should stop talking too much about random things. So we go into it from the YY summary here. And then batch size, keep it at 100. That should be okay. Yep, should be okay to leave everything by default like this one. Okay, so the trigger is added. Now we can just deploy this one. And hopefully we got some data coming in. Let's go back to the uh, DynamoDB table. So I'm opening a new tab and go into DynamoDB here. Just go in inside the table, go in inside here and items. Yep, we got some data coming in. Okay, so that's good. That's already finished covering all of this, like from Kinesis. Going to do a quick ETL on that using data analytics SQL here, and then put back onto another Kinesis data stream. Then use AWS Lambda function to get the data out of the data stream here and put it onto DynamoDB directly. So that's one of the steps that we can do. Other step is more important in my mind because normally like you don't just run a very quick and short queries. You want to have the ability to store the data stream so you can deal with it later, including trying to do maybe more advanced machine learning and AI with this. So the best thing is after you got the data coming from the producer to Kinesis data stream here, you go into use Kinesis data file host as the consumer and then put it in S3 on an S3 bucket. And then you go into your Amazon Athena, very similar to data table on the Databricks, and just run SQL query on that. Another stack that I introduced here today is after you have the data on S3, maybe you want to use Spark to do some machine learning with that, or trying to do some like ETL using the Spark SQL instead of other SQL services here. So the way that you can do that is trying to use the EMR on AWS. So we're going to do that first before we go into do the module 4 here, mainly because it will take you guys about 15 minutes to put up the EMR cluster on AWS. So from here, just leave that. I'm just going to EMR. So EMR here short for Elastic MapReduce. So this is the cluster, the managed service of AWS that allows you to run big data Hadoop and all of the big data stack on this one. So just going in here, click create a new cluster. Just put any name, for example, Kinesis tutorial. Keep all of this by default. Actually, we have to go to advanced option. So the reason why we have to go to advanced option because we want to have the ability to select which stack that we go into add onto our cluster. I'm going to use the latest version, and I'm going to need Jupyter because I'm going to use the notebook to do the job. So I'm going to select both Jupyter Hub and Jupyter Enterprise Gateway here, which allow me to run the notebook. Then I'm going to use Spark as well because I'm going to run the Spark SQL query on that. You can add any of these if you want to play around with them. This is super easy to set up compared to, I know there's some tutorial out there asking you guys have to put up the EC2 instance and then go in there and do a lot of installation in there. This is much easier to deal with rather than going with the installation before where we have to do everything by ourselves. I'm the lazy one, so I'm going for the easy version. Okay, I'm just select use Spark for table metadata. So if you go into deal with clue data catalog, then you can select this one. If you don't, then don't select them. I will introduce clue data catalog in the next tutorial. And inside here, there's a couple of things that we need to pay attention to. First one is the networking. So normally like the default VPC is good for most of the service on here. If you happen to like change the setting of the default VPC for some of other purpose, like I did in one of my other account, like I update that. So you need to create a new VPC that have the public setting. So if you fail at this step, which means after you follow this step to put up the cluster and it fail, it's highly likely that it's because you have the wrong VPC here. Just go in here, launch VPC wizard, and just create a new VPC with single public subnet. Select here and just create here. It's pretty straightforward. Just put the name here. Don't update anything if you don't want to mess up with that or if you don't really understand that. Okay, here if you have the cluster node and instance, just define like how many you want. For example, here we have by default one master node and two worker node here. Leave them as is. EMR is really good with auto scaling as well. So they have the cluster scaling here managed by EMR. So you can just set the maximum and minimum of number of worker node here that you want to increase. We don't scale the master node by default. If you want to scale the master node, I think previously, I think I missed that. I think there's a setting here. Here you can use multiple master node. So this is on the new Hadoop. So you have multiple master node to allow you to have more availability. This from Hadoop tree. Going back to this one. Yep. So we really don't need scaling for this one. So just uncheck that and click next. Leaving everything by default. Changing the cluster name here if you want. Just Kinesis tutorial like this. Okay, and click next. And here you can select the EC2 key pair. If you are unfamiliar with this, please don't update this. But if you want to study more, EC2 key pair is like it's just like an SSH key, or you can use PuTTY with that as well to access the EC2 instance with this is quite key. Let's say like that to put that simple. Just leave no key pair here. Okay. Create cluster. So that will take 15 minutes. I don't know about that time. You should create a notebook as well. It's going to fail because the cluster have not up yet, but we just created in advance. So we have less waiting time later. And just choose the existing cluster, choose the cluster that you are creating. That's it. And leave everything by default. You can link a Git repo inside here, but it's easy to link it later inside the notebook, so you don't need to do it in this step. Okay, just create, leave everything running. This is going to take a long while. Meanwhile, let's go back to the tutorial here where we create the consumer for the data stream here. So we consume this Kinesis data stream, and then we use data file host in Kinesis to consume the stream, and then put it on S3 and use Athena for query, Athena table for query. First thing first, we're going to need to create the S3 bucket. So just going into S3. And create the bucket here. So it can be any name, but if you want, just keep this name so that it's consistent. And the bucket name has to be unique, so please don't type exactly as me, which means don't put my name here. And here you have some setting. For example, if you want to put another regions, or if you want to have bucket versioning in here, add in some tag or some encryption. But normally just leave the default, should be good enough. Okay, so we created the bucket. Next step, we go into create the Kinesis data file host to get the stream coming from the data stream into that. So going back to Kinesic. Now instead of creating data stream or data analytics here, I'm going to create the delivery stream. And just call it any name. And I'm going to use the Kinesis data stream as the source here, using wide as the input. Now I'm not going to do any transformation with AWS Lambda or convert the format, just leave it. Now the destination would be S3 bucket, choosing the bucket here. And we really don't need any prefix because it's automatically created the prefix, starting with the year here, then going down one level to the month, then going down one level to the day, and one more level on the hour. For the buffer size, just to save some money, you can decrease this one. You can do compression for other purpose. For this tutorial, just leave them as is, and we're going to create or update this IAM role here. Just click next and create delivery stream. Okay, this is going to take a little bit until the data coming into S3, but let's just check in that. Going inside here. It's going to take a couple minutes. Be patient. Just checking this sometime to see if the producer is still working. Yeah, I'm normally very impatient, so in some of my video, you will see me cut out the part where we have to wait a long time. Uh, Anyway, I should not be stupidly sitting here and refreshing this until it's coming up. Let's move on. You will see those coming in later. Don't worry. Now let's try to move on to create the Amazon antenna table. So as I say, the Amazon antenna table very similar to the data table on Databricks. They just going to leverage the SQL power to help us to query the data that's stored in the raw format on S3. Okay, so let's go to Athena. Oops, wrong one. Go in on to Athena. Hey guys, you see a bit of time jump here because I need to be away from keyboard. And second reason, EMI is taking longer time to be up than what I expected. And thirdly, I found a little bug in my Python producer code. So the bug is basically I have the different format for the timestamp here, which is not going to work well with Hive SQL. So Hive SQL requires you to have strictly this format, year, month, day, with 4 digits for the year, and then hours, and then up until millisecond with only 3 digits on the millisecond. So I have to update the producer here to allow with that. You guys will be fine because I'm going to send you guys the correct version only. Just pay attention to the timestamp here. I totally forgot that the format of it has to be like that. So because I updated this one, I have to stop Bob the producer here. Then I have to go into S3 bucket here and empty everything. Then I start the producer, the two producer again, so that the data coming in the correct format. So now the data should be coming in already. Now we can start to run some query on this one. Okay, if you're using Athena for the first time, you have to identify the query output location. So please don't use the one that we going to deal with the data here, otherwise it's going to mess up with the table that we have. So it's highly recommend that you have a dedicated bucket for the Athena output. So just create a new bucket, call it Athena query results like this one. And yes, of course, many people would have that same name already. So we have to put this as unit. If you want, just put your name here as well, making sure the bucket name is unique. Okay, now after you created that, you can select it from here, or if you remember it, you can just type it in, but I just going to select it. So that would be the output of all the SQL query here. If you already have the table before, like me, if you run this multiple times, just drop the table first to make sure you got nothing here. Then just copy this bit of code or item from the tutorial here. So basically this one going to just create the table if not exist with this schema here. And then going to with the file as JSON because we did send the JSON. So we going to with the JSON and we're going to use Hive SQL. That's why we have to be aligned with their timestamp string format. Let's just don't worry about that one. Run queries. We got the table coming in. Now let's just preview table. And you can run queries a couple of times to see here. Yep, we got some data coming in. Okay, so that's good. Let's cover a little bit about how we can use SQL on top of the S3 buckets. Very similar way to the data table on top of the files on Databricks. Now let's move on to EMS. So just check whether your cluster is up and running. The status should be like this. Then go inside the notebook here. See if your notebook is currently running. If you don't see it, just click Start button here, and after it's starting, then you can see the button open in Jupyter Lab appear here. Then it will redirect you to the Jupyter Lab in here. So now you can just run a Spark notebook on top of this. I already have the assemble for you guys. So inside here, we have the notebook Spark assemble, which just includes some very basic introduction on how to use PySpark on the EMR here. So when you open the notebook, just make sure that you got PySpark here at the kernel. So if you select other things, it might be different because here we got the native Python, or you can have the Spark or Spark R, but we're going to use PySpark, so select this one. So with the PySpark kernel, anytime you preference either Spark or the Spark context here, a new Spark application will be started. This check-in info is actually outdated, so we cannot use it. Just ignore it. So because we're referencing the Spark session for the first time, it's starting a new Spark application here. Okay, the Spark session available as Spark, and the Spark context will be available as SC. So the Spark context is helpful if you want to install custom package. For example, here they only have Boto. Boto is just a Python library that allows you to use other AWS service directly on Python here. I'm more familiar with Portal 3, so the newer version of Portal. That's why we go into install Portal 3. So the way we can install any custom package, not custom, but like other Python library package, just go into call the Spark context here and install from PyPy package. And then go into check the list of package again. You see Portal 3 is already in here. Okay, so this is just a quick introduction to Portal Tree. So Portal Trees allow you to use some of the resource here. Today I'm just going to show you how to use the S3 one. Very simple assemble. There are other assemble later where I can show you where Portal Tree is used with IAM or other AI service on AWS. So here we call Portal Trees resource and we're going to use the S3 resources. I'm just going to use it to list all of the file under the folder that I created for YY. So just update this one to the bucket folder that you have. Prefix name 2021, which means just the folder that we have for the data now. If you have multiple year data, then you probably have to do this multiple times to get the list of everything. Okay, so this is all of the data I have. Let's try to read the first file in. So I'm going to use Spark with JSON because this is a JSON file. Even though this don't have the file extension, you know that you send in the JSON from the producer here, then it should still be in JSON. If it's in other format, which means you already do some other data transformation, so that's something else. Okay, let's just print out the data frame here and check in. So I'm just creating a summary table. It's stupid here because in this one we only have one instance. So the summary table does not work. But if you have multiple data, then you can have the multiple version here. Sorry, multiple statistics here. Okay, so this is just basically show you how to get data from a file on S3, then doing some very similar statistics data transformation, let's say like that. Don't just limit yourself to statistics, some data transformation. Then you can do some machine learning with it as well. And then just if you need to, like put the file back onto S3, save the output, back to S3, or you can try to do some machine learning on top of here and save the model out on to S3 as well. Okay, so this should be a good introduction on how you can use EMR on the EC2 instance here on AWS and trying to put up a fully managed Spark cluster so that you can utilize the Spark and Spark ML lib that we learned before to do assignment 3. If you want to go with this stack, like I'm not limit the stack, so feel free to do whatever you want. Okay, so that cover everything that we have on this tutorial. Now the last step is going to be, uh, let's say, the last step is going to be boring, but it's important because we need to clean up all of this. We don't want to keep them running and got charges for that. So just stop the producer. And now we go into delete all of this. So since I'm already on EMR here, let's just stop this one and delete the notebook as well. So this is not in the stack that they have. So it is something I did on my own. Have to deal with this on my own. So here, if you delete the email cluster by default, some of the cluster have termination protection on. You have to check it to off first, and then you can terminate. A lot of deleting step on here, you have to do it multiple times, like confirmation multiple times, so that they can protect you from accidentally delete things. Okay, if you don't want to keep data on S3, since we still on S3, let's just empty. So with S3, you have to empty all of the item inside the bucket before you can actually delete them. So permanently delete. So after you empty the bucket, you delete the bucket by typing the bucket name. I'm going to empty this one as well. Normally, like S3 doesn't cost that much, so you can just leave them on if you want. And this account is AWS Educate account, so it's not going to hurt. You guys can totally skip this step. Yeah, but I'm just going to do this so I can say that, yeah, I teach you guys the proper things, which means trying to manage the resource. Uh, permanently delete. Okay, last one, empty here. Okay, so that's done with S3. EMI is still terminating. You don't need to sit here and wait. Let's go to Kinesis. So we're going to delete everything on Kinesis. So data stream here. Delivery stream. Data analytics. Yep. Everything on here has been gone. Now we need to deal with DynamoDB and Lambda. Table, delete table. Don't worry about the auto scale configuration. Lambda and delete this one. Okay, Cognito. Manage identity pool here and just click on this one. Edit identity pool and delete. Okay, after this one, what else? Yeah, you can delete this table as well. Just run the query top table. It's going to fail because I already removed the bucket for this one. Don't worry, like Athena table doesn't cost us much. Leave it there. I should have done this in the correct way, which means delete the Athena table first. Okay, just looking at the list to see if I'm missing anything. Yeah, that should be it. Normally you don't need to delete the IAM here, but okay, let's just quickly show you guys the IAM deletion as well, just to complete it. So in the home, just search for anything related to wireless, which means we know that it's related to this workshop here, and delete this one. Since we create user manage policy as well, so if you don't want to keep the policy, then you can delete them. Keeping these doesn't hurt, so normally I would just leave them to the point I have way too many policy and roles that have similar name, and it's really painful to know which one is which. Okay, that should be it. Thank you guys for joining me here today. We cover pretty much everything in the stack, including some other new thing as well. So of course, I remove Cloud9, but I add in the Python producer, I add in the EMA. Next tutorial, we're going to deal with Glue data catalog, as well as trying to connect the data after we run the query with Athena here, then we can just output that onto a visualization dashboard. And I'm going with Power BI. Okay, just disclaimer here, I'm not going to teach you guys Power BI, so you guys don't complain to me about me teaching too much. What I'm teaching is actually how to connect data, moving data from A to B to C. That's it. I'm not actually teaching Power BI. Okay, I hope you guys enjoyed this tutorial and I will see you on the next video. Bye guys.